Hello everyone, and welcome to today's session. My name is Mark Westerway. I am a driving simulator engineer here at VI Grade, and I will be your host for today. As always, this webinar is being recorded, and the video will be made available on our webpage soon. Also, before we get into everything, please make sure you are currently set to mute to avoid any accidental interruptions. So, joining me for today's session is Dave Bogemer, Director of NVH Solutions here at VI Grade, and shortly he'll be taking you through all things NVH and driving simulators. At the end of the presentation, there will be a Q&A session, so please, during the presentation, use the WebEx chat function to send any questions you might have directly to the VI Grade WebEx chairman, and we will answer them at the end of the presentation. So without further ado, I will now hand over to Dave.
All right, thanks, Mark. My name is Dave Bogemer. I've been working with the NVH simulator in various capacities for the last 15 years as an application engineer and technical expert and product manager, and now as the director of NVH Solutions here at VI Grade. We're going to be walking through what the NVH simulator is and how it helps us with the automotive development process. So to start with, a very quick introduction of the NVH simulator. We'll of course go into more detail about this throughout the presentation. But the simulator is, the Brüel and Kjaer NVH simulator technology is the latest addition to the VI Grade suite of simulator and simulation tools. The NVH simulator technology enables NVH virtual prototypes that can be used to experience sound and vibration just like driving a real car. The keynote of this is highly accurate sound and vibration. You want to be able to create sound in a way that is exactly the same as what you would experience in the car, so you can make the right decisions in the design and development process. And these NVH simulator models or NVH virtual prototypes are a combination. They can be a combination of measured in-vehicle data, measured component data, and lots of different kinds of CAE data. And bring all those together in a single unified model so you can assess what the car will actually sound like with all of this data in one place. So some of our audience today is familiar with VI Grade, but possibly unfamiliar with Brüel and Kjaer. Others may be more familiar with Brüel and Kjaer, but less familiar with VI Grade. So before proceeding too far with the NVH simulator, I'm going to briefly introduce both VI Grade and Brüel and Kjaer and show how the central message and vision for the NVH simulator integrates perfectly with VI Grade. So VI Grade delivers solutions which bridge the gap between testing and simulation to accelerate product development. These solutions embrace a number of domains and a number of different attributes. VI Grade delivers software and simulators for vehicle dynamics, ride and handling, ADAS and autonomous vehicles, HMI, motorsport, and now NVH. And this slide summarizes how VI Grade are bridging that gap between testing and simulation. So starting from the concept, from the CAD drawings, the initial CAE analysis and that sort of thing, we build up a model that's an offline model that can be interrogated and used. We then move to an online driver-in-the-loop type simulation. We can even move into in-vehicle simulation, so simulation in a real vehicle, and ultimately to the sign-off. The basic idea here is that instead of getting an idea and making some hardware and trying it out, we're shortcutting that, and we're saying, well, we're going to get an idea and we're going to simulate it. We're going to try some things out first, and then once we have a pretty good idea what we want, then we'll build hardware and go from there. So really, we're shortcutting that whole traditional process and breaking the rules of traditional automotive development. So who are Brüel and Kjaer? So Brüel and Kjaer are world leaders in sound and vibration. They've got a 75-year history, more than 75 years of innovation history. Brüel and Kjaer was founded in 1942 in Copenhagen, Denmark. And Brüel and Kjaer have been at the forefront of sound and vibration measurement and analysis for over 75 years, serving all major markets. In terms of automotive measurements, Brüel and Kjaer has a lot of solutions that are very specific and tailored to the automotive measurement and analysis area. Brüel and Kjaer are known for their high quality, accurate, dependable, and durable sound and vibration transducers, data acquisition equipment, and analysis software. A couple examples right up at the top, the head and torso simulator, or binaural head, is kind of unique because it very accurately emulates what a human head and body represent in the sound field, and even the ears are shaped like a human ear. The wearable binaural microphone enables you to record sound where you can't put this guy. So if you're the driver, you can use this, and this is the most accurate, most comfortable, easiest to use binaural microphone on the market right now. And there's lots of other solutions that Brüel and Kjaer provide to acquire data and analyze that, and we use that to feed the NVH simulator with noise and vibration data. Now, I usually get a question: do we have to use Brüel and Kjaer equipment to feed the NVH simulator? No, we're very open. We take data from anybody, but there are streamlined, tailored methods to get in data from the Brüel and Kjaer solutions too, as you can imagine. All right, so a question I've gotten asked many, many times for the past couple of weeks: why is the NVH simulator part of VI grade now? Well, the simulator has existed at Brüel and Kjaer for about 15 years. VI grade and Brüel and Kjaer are sister companies, and they're part of a company called HBK, Hottinger Brüel and Kjaer, which is a recent merger of HBM Brüel and Kjaer. What we decided to do was consolidate all of the automotive simulator and simulation technology under VI grade. And it really was, once we took a look at it, it just made a lot of sense to do that. Combining the NVH capability and the NVH simulator solutions with the existing VI grade simulators and simulation enables the engineering of multiple attributes with an integrated set of simulation tools. It also allows us to leverage technology between the different domains and come up with simulators and simulation solutions much easier and faster. Of course, we're going to maintain our close ties with Brüel and Kjaer measurement analysis systems, solutions, and engineering services. That's been a winning combination for many years, and that's going to still be there. It's just we're reorganizing the core resources under VI grade for the NVH simulator solutions. And if we look at the existing lineup of VI grade simulators, the NVH simulators follow the same progression, going from a desktop up to a full vehicle simulator, and even with the dynamic simulator, we can use the NVH simulator solutions together with the existing VI grade solutions. So we can combine multiple attributes simulation together even today. So let's talk about NVH. The purpose of NVH design and development is to design and engineer the sound of your vehicle to meet the brand and customer expectations. And you want to be able to do that before you even build the first prototype. You want to know what you're designing. And just to take a step back for anybody that's on the call today that might not be super familiar with NVH, NVH is simply automotive sound and vibration. It covers the frequency range basically from about 5 hertz up to 20 kilohertz. in anything that's vibration or sound. Now that could take the form of powertrain sound and vibration. So that's anything coming from engines, motors, gears and shafts. And you'll hear lots of different terms for those. I've thrown a few up here with shake and boom and tonal gear noise, engine combustion, moan and growl. These are terms you would hear for powertrain NVH issues. For road noise, we really go all the way down in frequency to cover what we call secondary ride. Anything created by the road that comes through a structure-borne sound or vibration, airborne tire noise that comes right from the tire tread. Of course, you have wind noise that's quite broadband, and really anything else in the car that makes sound or creates vibration falls under the domain of NVH. So HVAC systems, brake squeal, chimes and warnings, anything like that falls under the dominion of NVH. All right, so why is sound and vibration important in vehicles? Well, NVH is one of the main attributes controlling and delivering vehicle refinement and brand DNA in vehicles. So if we look at just the factor of comfort, you know, how annoying or pleasant something is, how loud the car is perceived to be. If we look at a feeling of quality, it's interesting that consumers make judgments about products, about cars, based on what they hear. And those judgments may not be accurate at all. Just to take a very obvious example, you know, if they go to the dealer and they go for a test drive and they get in the car and they try to adjust the seat and the seat motor goes, it sounds like the seat's going to die, and they shut the door and it sounds kind of tinny and weak. Before they've even turned the car on, they start thinking, wow, this is kind of a piece of junk. It's not going to last very long. It's not going to be very durable or reliable. Which actually, those two sounds have absolutely nothing to do with the reliability or durability of the car, but the customer starts thinking that way. So that conveying that feeling of quality is really an important job of sound and vibration. Then you have the overall character of the vehicle. What's its personality? What is it communicating to the customer? What kinds of emotions is it driving in the driver and the passengers? And also driver satisfaction. Is it meeting the customer expectations? You know, if they buy a luxury car, does it sound refined and smooth and quiet? Or if they buy a sports car, does it sound sporty? Does it sound powerful? And then outside the car, all the same ideas here, conveying character to those around you. You know, when you drive by, what do people think about the car based on what it sounds like? But also, you know, pedestrian warnings and things like that are becoming more and more important in our car designs. And this all sums up into the brand DNA. What is it that the brand stands for? What's the personality of the car or the particular model of the car? We're communicating all that with our NVH characteristics here. And with this image here, you can see that's driven by a number of different parts of the sound. So we can play with and tune the different parts of the sound to deliver this brand DNA. Now, vehicle NVH affects several things that are pretty important to commercial success. So it affects the initial buying decision, obviously. Even if people aren't conscious of the fact, they're not consciously making decisions based on sound. I mean, maybe they do. Maybe they go to the dealership and they say, I want a really quiet car, or I want a car that sounds really powerful. But a lot of times they don't even consciously think of that. They just get in the car, it feels comfortable to them. In the sound and vibration are just conveying the character to them. That affects their initial buying decision. NVH also affects warranty costs and customer satisfaction. So, you know, 3 months down the road, do they start noticing something annoying about the car, or do they start hearing some gear whine? You know, if they take the car into the dealer and they say, gosh, it's making this whining sound. The dealer will have to spend time troubleshooting it. Maybe they'll even replace the axle or the transmission to try to reduce the gear noise. And there may not be anything functionally wrong with the car at all. It may be that transmission will last 400,000 miles, but we're incurring warranty costs because of an NVH design that didn't adequately protect for that. On the flip side, if you get NVH right, your warranty costs are less. And same thing for customer loyalty and repeat buyers. If people are unhappy about the sound and vibration characteristics, they aren't going to maybe buy that car next time. But if they love it, if they love everything about their car, they're delighted. They'll tell their friends about it. They'll buy another one. So it has a lot to do with the success of the vehicle. All right, so I'm just going to switch slightly the presentation mode here because I have a couple of videos coming up, and I just want to make sure that in WebEx you can switch the quality to optimize for that. So I'm going to do that right now. So we should still see the same screen here. All right. So some of the current NVH challenges. Lightweighting is getting a lot of focus right now, both for increasing mileage and increasing range of electric vehicles. We want to make the vehicles as light as possible. So reducing mass has a lot of effects on NVH. Less mass allocated for sound package, less mass that we have to put in damping material and absorption material. Lighter structures, lighter vehicle structures tend to transmit sound more easily. So it makes the job of the NVH engineer a lot more difficult. But at the same time, customers aren't really concerned about that. They expect that their next vehicle they buy is going to be as good as or better than the last one they bought. And they don't really, they're not really in the mindset of trading off, accepting a louder car because it's lighter. That's not part of their mindset. So we have a challenge here to deliver the same level or better performance with these lightweighting challenges. And then, especially with electric vehicles, we're draining the swamp. So we've got a lot of things that are traditionally masked by engine noise that are now audible. So this nice pristine swamp here that looks beautiful and serene, when we start draining that, we find out there's some alligators in there. Things like air conditioning compressors, power steering pumps, motors and gears that are making noise that you couldn't hear before. So we have to be aware of that. We also have a loss of character. So the internal combustion engine can add a lot of emotion and a lot of feeling to the car and to the personality of the car. When we move to electric vehicles, we have to find a way to still have that emotion in there. And then we've got legislated minimum noise generation. So as we know, electric vehicles have to make noise now. So we need to make sure that sound that we're generating outside the car matches the character, matches the brand DNA of the car. All right. So with a lot of different engineering types of data, you can just do your analysis or make your measurements, look at a computer screen, and make a decision right away. You can see how the heat is transferring or how the air is flowing or how something is bending. And you don't have to have you don't have to translate that internally into what it means. You can just see it and make a decision. NVH data is different. We get a lot of great information from measurements and from analysis and from calculations, CAE, and that's all in the form of plots and graphs and numbers, and that's all great. We can learn a lot from that, but when somebody looks at this and says, well, this lower plot here, does it sound good? Well, I don't know. I mean, I can tell it's a 4-cylinder car. I can tell there's no big resonances or anything in it, but does it sound good or does it sound better than the competitor? It's really hard to say yes or no. You know, you look at this middle one, the blue and the red line. Somebody says, well, which one's better? You know, I don't know. The blue one is generally shifted higher in frequency and a little bit lower. Does it sound better? I'm not sure. So that's where the NVH simulator technology really comes in. With the simulator technology, we can take these numbers and plots and graphs and convert them into something that we can understand as humans, because we don't listen with our eyes. We listen with our ears, obviously. So with the NVH simulator, you can drive a car just like you normally would, and shift, and use your pedals, and change between sounds as you're driving. So as you're driving, you can instantly switch back to back between the sounds and really understand what all of these component parts of the sound really mean. All right, I'm going to again switch the mode here, which may take me out of sharing mode for a second, but we'll be right back. Go. All right, so we should be back sharing the screen here. Good. So with the NVH simulator, we can take data from lots of different places. We can take data from customer preference, customer satisfaction type data, you know, the recordings made during that type of thing, benchmark data, component test data, all types of CAE data, and we can bring those into one spot to evaluate those. And that's just one holistic virtual prototype. That's really important because, you know, as an example, with CAE data, you can generate sounds in lots of different CAE packages. Let's just take, for example, the sound of the exhaust. You know, simulating exhaust noise is a pretty robust technology now, pretty mature. So you can generate the sound of the engine at the exhaust pipe during a run-up. The problem with that is that even though that's very accurate and very believable, nobody listens to the sound of their exhaust pipe as they're driving the car, accelerating away at second gear wide open throttle. What you need to do is you need to take that data, translate it into the interior of the car, apply a transfer function to it so you understand what that means inside the car at the driver's ear, mix it together with all the other data that's there, so all of the road noise and the wind noise and the other engine noise and anything else that's going on in the car. Then you can listen to it in the right context and understand what that really means to the overall design of the car. That's what the simulator is all about. Once we have this all together, it's very easy to communicate these NVH concepts to people who need to know, who need to make the decision. So your chief engineers and program managers and NVH specialists, they can assess all of your NVH data in a realistic context. So another way I like to look at this is we can look at the vehicle development process. And this is the old traditional vehicle development process where we start the program, we set some targets in terms of numbers and lines on graphs. We start developing, we make some prototypes. Those are usually mule type prototypes. They're pretty early, pretty rough. We go along as we update the design, we update the prototypes. And really, by the time we get an NVH representative vehicle to drive, we're pretty late in the design cycle, well after hard tooling cutoff. So any problems we find here, we need to fix by adding cost and weight to the vehicle. And the NVH engineer, as an NVH engineer, you're nobody's friend at that point, because what we're trying to do at this point is reduce cost and weight in the vehicle. So we need a better way to do this. So instead, what we want to do is take this point where we can listen to a representative vehicle all the way back to the very start of the vehicle development process. So even when you're making basic architecture decisions, you know, are you going to use a 6-speed transmission or a CVT? What is the hybrid version going to sound like versus just the IC version or versus the fully electric version? So you can do a lot of basic studies back here. Then you're going to set targets. You're still going to set targets with numbers and plots and graphs, lines on a graph, but now you can listen to them. You can listen to what those targets are going to sound like and know what your vehicle will sound like if you achieve those targets. So you can get agreement on those targets very early on and get sign off on the targets right away. As you go through the development process, you're going to be able to update these virtual prototypes instantly, which is very different from a hardware prototype. So when you make design changes and you want to create some hardware to test, you know, that could be 4 weeks, 6 weeks, 8 weeks to get that hardware built and onto a test vehicle and test it. It can take quite a while. With the virtual prototypes, that can be done immediately and listened to immediately. So your virtual prototypes are always perfectly in sync with your design. And you can use these virtual prototypes for the entire vehicle development process. So obviously, this enables the reduction of physical prototypes. And whether as an initiative to, you know, say, hey, we can reduce physical prototypes by being able to do a lot of this in virtual prototypes, or, hey, I've just had my vehicle prototypes taken away from me. I don't have these early prototypes anymore, but my executives still want to drive a car. The NVH Simulator fills that gap or that need there. Just a word on current customers. I mentioned the NVH Simulator technology has been around for a long time. It's been around for over 15 years. It's used by many automakers around the world. We've got 43 NVH Simulator systems installed worldwide. 35 of those are at automotive OEMs. Each one has one or more of the systems installed there. So the technology is very mature and proven. And also, we continue to update the technology. We have a dedicated development team focused on NVH Simulator development. So it's a constantly advancing technology and constantly advancing capabilities in the software. Now, as just a brief overview of the NVH Simulator hardware and software, the technology can be applied in several ways. The NVH Simulator software is at the core of all the solutions. So the NVH Simulator software, it does many things. That's where you create your NVH Simulator models. It has everything in it for controlling the models. In the simulator itself, it's based on the idea of source path receiver. So you can put in your source levels and your path sensitivities in your receivers and calculate receivers. So that's all built into that. So you can use that as a desktop simulator. That's kind of the workhorse version. So you have interactive capabilities where you can drive the simulator and the simulation right on the desktop. You've got the full vehicle simulator, which has all the capabilities of the desktop simulator, but in a much more immersive environment and including vibration at all of the vehicle, at all of the driver touch points. You've got the on-road simulator, which takes NVH Simulator models and puts them into a real vehicle and lets you drive the NVH Simulator models on the road. Then we've got the exterior simulator to enable us to assess the sound of the vehicle outside and what is somebody going to hear when it drives by. Now, with all of these, we're going to be creating highly accurate sound using speakers or more commonly headphones and using high-quality shakers for all of the vibration. And then we have SimSound. This is what we use to play these NVH simulator models and create high quality audio on any driving simulator. Not an NVH simulator, it could be anything. It could be a simulator for anything at all. So let's go into these in a little bit more detail. The desktop NVH simulator, this is where you build all your models. This is enables you to drive these models interactively. So you can use a wheel and pedal system to accelerate and shift and control the vehicle as you would a regular car. So it's a complete driver in the loop experience, and as you're driving it, instantly in real time is creating the sound that you hear. You can switch back to back between different vehicles. That was shown in the video. You can also have a much more detailed interface for driving the simulator, where you can build up the model from all the different component parts. So the road noise, the wind noise, the powertrain noise, HVAC noise, whatever. You can even break those down into even more granular parts. So you can say, you could have parts for each engine mount, for example. And each one of those you can turn on and off. You can increase or decrease their levels for each of those parts independently. You can filter those with a wide variety of different filters. So, you know, if you want to shape the sound or notch out a particular frequency or something like that, that's something you can all do in real time as you're driving. So it gives you tremendous flexibility and power to understand the data that you're listening to and looking at. It also enables, it also has real-time visualization. So you do have plots and graphs playing at the same time as the sound is playing, so you can correlate the objective measures to what you're hearing very easily. The simulator also has a complete jury analysis suite built into it. So you can capture the opinions and driving behavior of people who are assessing the vehicle. So you can do a complete evaluation or jury assessment in the simulator using the software that is built into the simulator. So the full vehicle simulator has the same capabilities as the desktop simulator, but it's built into a vehicle body or vehicle shell. And we add vibration, and that vibration is calibrated. It's independent from one another. So it's multi-axial independent vibration that's calibrated. So when you shake the seat vertical, the steering wheel doesn't move. When you shake the heel point, the seat doesn't move, or the steering wheel doesn't move. All of these are completely independent. They're not tied together. So that gives you incredible control over what you're delivering to the driver. So you know exactly what you're doing, and there's no crosstalk between these different transducers or shakers here. That's really important when you're doing detailed evaluations, especially for target setting. If you're trying to set targets for what's acceptable for idle vibration, for example, you need to have very accurate, very calibrated vibration to make that kind of assessment. So this kind of a system enables you to do that. The on-road simulator and Vsound enable you to take your NVH simulator models and play those back in an actual vehicle. So we tie into the CAN bus of the vehicle, and we synchronize the sound playback to vehicle speed, engine speed or motor speed, accelerator pedal position, gear position, really anything else that you need to tie the sounds to. If you've got a sport mode, you can switch between modes. All that stuff is possible in the vehicle. And we would normally play this back either, we couldn't use headphones, we can play it back over the existing speaker system in the car, we can add extra speakers in the car, and we can do all this with multi-channel audio. So we're not limited to 2 channels. We can do 8 channels or even more if we want to. So we can play back sound inside the car, outside the car, or both. I'm not going to get into the details of what's different between the on-road simulator and Vsound so much, but they're just slightly different solutions that enable you to play back your simulator models in a real car. The benefit of that is that your context is perfect. It's not like driving a real car. It is driving a real car. And then what you're doing is you're layering these different targets or different design alternatives or what have you in terms of NVH on top of that, so you can understand what they mean in the dynamic situation of driving a real car. All right, now sound design is a big topic now, especially with active sound design solutions, both for cars with IC engines and for electric vehicles that need to have some sound added. You know, getting the right sound that matches the DNA, that matches the personality of the vehicle is really important. So we do offer sound design services, but more importantly, the NVH simulator gives you a way to assess all of these design sounds in the right context. So especially with EVs and adding sound to EVs, it's very easy to go to a sound designer and who's sitting in a studio and come up with some really cool sounds that sound amazing. But those same amazing sounds, once they get inside the vehicle and get mixed with the road noise and the wind noise and the dynamics of the vehicle, what the vehicle itself is doing is it speeds up and slows down and goes around corners and things like that. That completely changes your perception of that sound. So being able to integrate those design sounds into the right sound environment in the NVH simulator gives you the ability right on your desktop to much more easily design those sounds and evaluate those design sounds and to tune that sound design right on the desktop. And that's another important point. Any kind of sound design that you do, whether that's engine orders to enhance engine sound or just unique sound for an electric vehicle, you want to tune that sound for the individual vehicle, for the individual model. You may have vehicles that have different numbers of speakers, different sound systems, things like that. Traditionally, that's done on the vehicle. You need to have a vehicle to do that. We all know that vehicle prototypes are hard to come by. It's very hard to get time on those. So if you can do the vast majority of that tuning on the desktop, you have a much shorter window that you actually need to validate that in the vehicle. And really at that point, what you are doing is you're just putting it in the vehicle to validate it, maybe do some minor tweaks at that point, but you're doing 95% of that tuning on the desktop. And then you can use the Vsound unit, again, to take these sounds out. If you don't have the exact car that you're going to use, if you want to just try these out in a car, great. Take those sounds, pop them in the Vsound box, put it in the car, and you can drive these sounds in a real car. We have the exterior simulator, which basically everything you can do inside the car, you can do outside the car in terms of assessing the sounds. So if you want to know what it's going to sound like when you're standing on a street corner and somebody drives by in the car or takes off from a stoplight, or if you're walking through a parking lot and the car starts backing out, what's it going to sound like? You can assess all that. And you can do that with different levels of ambient noise, because obviously if you're out in the middle of nowhere, the ambient noise is very low. If you're at a mall parking lot that's right next to a freeway, the ambient noise is totally different. You can do it with different amounts of traffic, so different amounts of traffic noise and things like that. So it's a great way also to assess all these things on the desktop without needing to go outside and do this in real life, which really is a theme for the simulator in general too. Even in its most basic application, using the simulator to just to assess benchmark vehicles. Doing that in the simulator decouples you from needing to have vehicles have them at the test track at the right time, coordinating everybody's schedule to be there at the right time, and then hoping that it doesn't rain or snow or have some other weather-related incident that's going to impact your evaluation. All that goes away, and you can do that in simulation because it's in a controlled environment. All right, I mentioned SimSound before. SimSound is basically a very reduced version of the NVH simulator. It uses the NVH simulator core algorithms to deliver very, very accurate sound in real time, synchronized with all aspects of the driving simulation. And this can be used to bring immersive, accurate sound to any driving simulator. And that can be a driver training simulator. It can be an HMI simulator. It can be a vehicle dynamics simulator. And this is the standard sound generation system for all VI grade simulators, of course. But what this does is basically it takes it from a point where you have some sound on a simulator that kind of sounds like a car, that tells you, sounds like there's something happening that's vaguely car-like, to being exactly the right sound. So, in this case, there's an article that we did a year or two ago with Ferrari, and it took them from, and this is a VI grade simulator they have too. So when they sit in their simulator and drive that simulator, if they're driving the 488, it sounds just like the 488. If they're driving the F12, it sounds just like the F12. So it doesn't sound like a car, it sounds like the car. I've also mentioned a lot about CAE tools and bringing in CAE data. I would say that the vast majority of NVH simulator models are hybrid models. They're combinations of CAE data and measured data. And we've worked with a lot of the major CAE suppliers to make this transition of data into the simulator as easy as possible. And we're continuing to work on that, expand that capability to other suppliers and to make this smoother every day. For some data, we need to convert that. We get punch files, or we get some other format of data, and we take it through what we call our CAE auditioner software to transform that into something the simulator can use. And that can be source levels, it can be path sensitivities, it can be contributions to the driver's ear. Doesn't really matter. We can use all that types of data. Other types of data we can bring right into the simulator directly. So just depending on the specific simulation you're doing, we can bring that. We have different routes to bring that into the simulator. All right, so we're getting close to wrapping up here. Hopefully, through this WebEx, you've seen that the NVH simulator and the simulator technology enables you to evaluate vehicle NVH data efficiently and experience the sound and vibration directly as sound and vibration, not as numbers and plots and graphs. And that enables you to make decisions more rapidly and with confidence. I think, a lot of us has been in the room when we're trying to explain why a 3 dB reduction at 500 hertz is really, really important, and spending an hour trying to do that with plots and graphs. That's about a 5-second discussion if you can let somebody drive it in the simulator. So you save time in many different ways, especially in terms of prototyping. You have your virtual prototypes ready right away. There's no waiting for hardware. And obviously you're reducing cost. You're reducing those early prototypes, which are very expensive, and less time spent on NVH design is a cost savings. So now this probably makes a lot more sense too. I mentioned that the NVH simulator solutions mesh perfectly with the standard existing VI grade message. We go offline to online to in-vehicle and enable this virtual prototyping approach to bridge that gap between testing and simulation. So I'd like to invite you to find out more. You can visit us on the web. Our website is vigrade.com. Absolutely contact your VI grade sales representative, and myself or any of my NVH colleagues would be happy to arrange a demonstration of the NVH simulator technology for you. All right. At this time, I'd like to open it up to any questions. And one of my colleagues here is going to look through any questions we have and present those.
Yeah, thank you, David. So, or Dave, I suppose. First question. BIW is most complex component of total NVH model. Does the fidelity of BIW model have a significant effect on the simulation? Are you still out there, Dave?
WebEx just crashed on me there, so I'm back.
Okay. Welcome back.
All right.
So I was asking the first question. I don't think I need to repeat it. So if you could just give us the answer, that would be great.
Yeah, well, that's a really good question. And in general, I mean, you could change that to any of the CAE data. Of course, the fidelity of the models and the data that you're feeding the NVH simulator have an impact on the overall simulation. The simulator should be looked at as a way to just experience any type of data. As we're early in the program, we understand that maybe that data might not be the most accurate. But as we move forward, our CAE models get more and more accurate. We update the we update the models and they get more accurate, and we can listen to those. And so, as with any model, it's as accurate as the data you put into it. So we're able to really what the simulator is doing is just taking the data we do have and enabling us to listen to it and experience it.
All right, so on to the second question. Does VI grade provide inputs for CAE?
So I guess I can interpret that a couple of different ways. Certainly, if you're looking for input data to feed into a simulator, into a CAE model, if you need sound and vibration data that's been created from a virtual prototype and you want to take that and loop it back into a CAE model, sure. We can certainly, we're creating that time domain data in real time. We can certainly capture that and then feed that back into a CAE model. I guess just because I'm not sure because of the phrasing what exactly the question was, on the other side, we do have inputs from CAE to the simulator. We've got lots of different ways that we can bring in CAE data as an input to the simulator. And I guess as one last point, and one thing I didn't emphasize in the WebEx itself, but the simulator is also very open for software in the loop and hardware in the loop simulation too, where we can tie directly into other software, other hardware that is running that might be taking care of other things. For example, the vehicle performance model. You may have a CAE model that's running the vehicle performance. Well, we can just tap into that and work with that together in real time.
All right. Question number 3. How is Vsound operated with a real car? If the real car is being driven on the track, then how is the real sound of the car filtered to only provide the observer with only Vsound?
That's a really great question. So Vsound ties into the CAN bus, so it knows what the car is doing. So essentially, the car becomes your wheel and pedals that you would have on your desktop system, right? Instead of having a controller, you're using the car as a controller, and then Vsound is doing the same thing as what you would do on the desktop simulator, generating the sound in real time based on whatever the car is doing. How we manage the sound inside the vehicle or outside the vehicle for that matter there's numerous different playback ways that can be used depending on what's needed. If the car you're using is significantly quieter than, and by significant, that's not a lot. That might be 3 dB quieter than the sound you're trying to play back. You don't really have to do anything to suppress the existing sound of the car that's there. If you and then you can play that sound back through the existing speaker system or other speakers that you add in. You can use open back headphones, which provide a nice transparent environment. If you're trying to play back sounds that are quieter than what exists in the car, there's other things you can do. You can use closed back headphones that are noise canceling. So in that case, you're reducing the overall level of the existing sound, and then you're generating all the sound from Vsound basically. Also, we've had customers using Vsound who take an existing car, and because it's relatively easy to apply sound pack to one car to make it quieter. If you need to just make it a bit quieter, you can kind of make a special Vsound evaluation vehicle where you can apply extra treatments to lower the sound inside the car to what you need for the Vsound evaluations. So lots of different things, just depending on the sound you're trying to audition and the car itself.
Okay, great. So we have a few more questions. Now that the NVH simulator is part of VI Grade, who do we contact for support?
So you're going to go straight to the normal VI Grade support channels, and everybody who was focused on the NVH simulator before is still focused on the NVH simulator. So we've got our normal support personnel, but you're going to contact VI Grade now, and then it'll get routed appropriately to whoever needs to deal with that. And of course, many of you know me or Mark Ullman Ward or Revathy, our application engineer. Feel free to continue to contact us as well.
Okay, then how long does it take to make an NVH simulator model?
That's a question that is very common, and it really depends on how detailed of a model you want to make. Like any model, it can be super simple or super complex. So it can take anywhere from 3 or 4 hours to including going out and measuring some data on a track, coming inside, preparing the data and driving it. It can be very quick for a very simple model. It could take a week or two if you're going to be instrumenting 200 channels on the car and doing a very detailed source path contribution analysis and creating a very detailed model. It could just, in that case, you're spending a week just instrumenting the car. So it just really depends on how complex the model is, but in essence, it's actually pretty simple to make a model.
Okay, then sort of in the same vein, how realistic does the sound simulation sound?
So if you were to go out and record a car on a test track and come back and make a simulator model of that, you decompose the sound into its various component parts, and then the simulator is recombining those in real time. If you were to do that and play back to back just a recording you made on the road versus the recompiled simulation of that, you wouldn't be able to tell a difference. Apart from the fact that oftentimes we'll take things like key rattles or little distracting sounds out, so it might sound actually a little cleaner in the simulation. But it's very realistic. It sounds just like you were in the car. And then beyond that, as you start adding in other types of data, CAE data, various types and things, it's going to be as accurate as the sound you put in. when we play back sound, we use calibrated headphones that are equalized so that what you're hearing going into your ears is exactly what you would hear if you were sitting in the car.
Good. So then how do I get started with NVH Simulator? What is the first step?
Well, just contact one of us here at VI Grade. You know, we can start off with a demo. It's very common to do a pilot project to start with to show how the technology works, and typically we like to work with the customer on those projects, so we're not just doing a project, but kind of educating you as we do this, so you can see how everything works and how the models are built and how they're you know, what data we record and that sort of thing. So yeah, so those are kind of like the first steps.
Okay, so I see we have at least one more question come in the meantime in the side chat. So I'll just read this one out. They're asking, a lot of the presentation was focused on engine slash powertrain noises, but how representative slash what would be used for simulating tire noise?
Yeah, that's good. So tire noise is something we also simulate in the simulator. Obviously, it's a big part of the overall sound you hear in the car. We've got various methods we use for tire noise. We can do a simple decomposition of road noise that we've measured on the road, and we can decompose that into airborne and structure-borne tire noise very quickly. We can use a more explicit source path contribution approach where we measure the source levels of tire noise, both the airborne and the structure-borne tire noise, and the transfer paths into the vehicle, so that we could, you know, you could take the tire source levels you've measured on one car or even a test rig and move those over to another car. So you can build up a virtual prototype from these component levels of the tire noise. So yeah, there's multiple approaches we can take with tire noise to simulate that with a simulator.